What if I told you that this comprehensive 12-page investment analysis of a DeFi protocol was created entirely by AI? No manual research, no copy-pasting from white papers, no spending hours on DefiLlama charts, just me typing Pendle and coming back half an hour later. Hi all, Renato here. In this video I continue my journey into AI workflows with n8n, and man, do I love and hate this thing. I built a workflow that uses AI to automatically create deep dive investment reports on DeFi protocols. Currently, it takes information from docs and DefiLlama and generates a report like this one on Pendle. After many hours of excitement and swearing, waves of highs and lows, I finally got this damn thing working. For those who don't know me, I'm Renato Budnic. I have a PhD in applied mathematics and professional experience in software engineering, but currently I'm working as intelligence engineer, where I produce deep dives very similar to this. The difference is that at work we focus on the technological side for CTOs and software architects, whereas here I wanted to try something new and focus heavily on the investment angle. In this video I'll show you exactly how I built it and how to work around some annoying n8n limitations that you're likely to hit yourself. The high level idea is pretty simple. There are 3 steps. 1. Do a web search for specific resources on the protocol. White paper, docs, DefiLlama dashboard. 2. Gather the data by using a separate pipeline for each source and consolidate into one big JSON. 3. Produce the report via prompt engineering by passing in the data and a template for the report. For the web search, I used 2 services in parallel, Perplexity and OpenAI web search, and then merged the results. I prompted them asking to look for specific sources for the protocol and to output strictly JSON with a specific schema, which I need to rely on in order to merge the results. Then I save it to the database job queue. More on this later. The next part is supposed to fetch the sources. I set it up so you can have many branches in parallel, one per source type. Right now I have only 2. One tries to scrape all the documentation and the other get the data for the protocol from the DefiLlama API. I would have liked to add branches to process the white paper, blogs, audits and GitHub repositories, but I didn't yet have enough time for that. At the end there is once more some merge logic to produce one unique JSON. Okay, so the DefiLlama API branch is quite straightforward, because one of the links I requested to the API in the web search phase was the DefiLlama homepage. So I just processed that URL to get the ID of the protocol on DefiLlama and call the API endpoint that returns historical TVL. Now here's where things get more interesting, the docs branch. Again, one of the web search results should be the main page for the documentation, which I would like to scrape entirely. For this, I wanted to try the Firecrawl scraping service, which I heard mentioned a lot. Right now, I'm just calling the map endpoint with the home page of the docs, but I've noticed it sometimes misses pages. I'm thinking about using the more powerful crawl endpoint instead. Have you used it? Let me know in the comments what your experience has been. To extract the page content, I first use the HTML to markdown mode, and then prompt OpenAI to clean the text, removing all non-relevant content like sidebar, footer, and so on. This works reasonably well. Before all that, actually, I sort the pages by URL, because Firecrawl won't necessarily return them in any sensible order. Sorting by URL means that they might still be somewhat out of order, but at least all subsections will correctly be grouped together. And finally, the fun part. The last stage of the workflow passes all the data we gathered in a prompt to an LLM asking it to create a report. To avoid too much AI slop, I wanted it to give a precise format to write the report in. So, with the help of DeepSeek, I created a template that has the skeleton of the report and saved it in a Google Doc. Each section has a short explanation and examples of what should go in it. I enclosed all these explanations and braces and then told in the prompt to the LLM to use these to guide the type of content that should fill in that section, and to write NA if there wasn't enough information in the provided data to fill in that section. My favorite part about this template is that it clearly identifies the various stakeholders there can be in a protocol, and then includes this table for each stakeholder that summarizes rewards, risks, and price exposure. So for Pendle, for example, we can see that governance lockers, i.e. we Pendle holders, get in the position by locking Pendle and are exposed to its price movements, whereas the fixed rate seekers can swap in other assets and then will be exposed to price movements only of those assets. Here I also developed 2 small sub-workflows that I feel will be very useful in the future. One for loading a Google Doc as a markdown string, and one for the opposite, saving a markdown string, in this case the report as generated by the LLM, into a new Google Doc. I'll comment on the final result in a moment, but before that I wanted to show you something pretty cool. As I talked about in my previous video, n8n and me really struggle with larger workflows. I'm not sure why, but for large workflows, it basically doesn't save the output of each node, even though it shows it to you. But then when you click execute on a following node, it gives you this workflow too large error and asks you to re-execute the whole freaking workflow. This was an incredible waste of time while developing the workflow, very frustrating, and it drove me crazy. Sure, there are some workarounds, like pinning the data of the nodes that are slow at computing and moving the manual trigger around to where you need it. But it's very tedious, and frankly, it just shouldn't be that way. I wanted something more robust. So after brainstorming with Gemini, I decided to implement this database-driven job queue pattern. The idea of a job queue is like a conveyor belt that passes data from one stage of the workflow to the next. Because this data is persisted in a database, this allows me to re-execute each stage individually, independently of the others. I implemented this as a single Postgres table for the whole workflow, with a JSON-B column where I dump the JSON produced by a stage of the workflow. There's also a tag column, a string used to identify the different stages, and a status column to know which jobs have been already processed and can be ignored. So at the end of a stage, I dump the full n8n JSON into the table, setting the status to pending. And then the next stage of the workflow gets all the pending jobs from the previous stage, loads the JSON and keeps processing it. Sounds cool, right? Well, guess what? For a long time this failed miserably, and I had no idea why. I was using a Postgres trigger to watch for new rows being inserted into the table and automatically trigger the next stage of the workflow. But I kept getting an error on the payload being too large. The fact is, I was getting this error on the node that inserts the rows in the table. So it took me quite a while to realize that this was not some limitation of the n8n ORM implementation, but rather a fundamental limitation in Postgres triggers. Apparently, they have a hard limit on payload size of 8,000 bytes, which is non-configurable. And this is way too small for the size of the JSON objects we are dealing with here. So I switched to just running a normal query on the table, and at first I was polling for this every 15 seconds. Later, I realized I could just connect the write data node to the read data node in n8n, and I would solve the trigger problem in such an easy way that it makes me embarrassed to admit how long I lost on this. So, how does this thing work, and does it provide any value? I would answer with a resounding yes, with expected limitations of this being a prototype and nowhere near production ready. The Pendle report, which I read 80% of, is really good, and I learned a lot about this complex protocol, which I knew literally nothing about beforehand. I have a feeling it was much faster than reading the docs, because the information is very structured and succinct, without any hyperbolic bullshit that is so typical for these projects. I still needed to ask a clarifying question to Perplexity after I read it. I didn't understand what the source of yield for PT token was, even though the report correctly mentioned you are just acquiring them at a discount price, but I wasn't familiar with the concept of zero coupon bonds, so it was a bit confusing for me. But then for other projects I put as input, like Hyperliquid and Yearn, the web search fails, returning either no URLs at all, or in the case of Yearn, an old inactive domain. For now, I just manually edited those, but I could add a feedback loop with an HTTP request node that tries to get those URLs, and if it fails, calls again the web search by letting them know that these specific URLs are not working. Or I could try other web search services that I can prompt. Let me know if there's any service you think I should try. Finally, citations in the final report would be nice, which is probably actually the lowest hanging fruit, because I can fix it by just changing the prompt I'm giving to the LLM. I'll share the reports I have for now and all the workflows in the video description. Be sure to check those out. So there you have it, a database-driven n8n workflow for automated DeFi analysis. Let me know in the comments what protocol you think I should run through it next. Thanks for watching.